Assalamualaikum everyone. Today we would be solving a problem that would be given to us. In this problem, what we would be doing basically that when we have been creating a two-stage combination circuit with using combination logics. In this, what we would be doing that in first stage, we would, if we are given an even number, its output would be displayed as an odd number, and our odd number would be without any change would be displayed as an odd number. But in the second stage, the output of the first stage would be taken, and the even number that would be given in the first stage as an input would be displayed as the same output of the second stage, and the output of the second stage uh, output of the second stage, even if it is odd, but its input was of the first stage was even, then in the second stage the output would be even. But what would be the case of the odd? That the case of the odd number would be displayed as an odd number without any change. So let me explain it to you with the help of this circuit. So first, I over here right now I've used logic props and logic gates to implement circuits uh, like in a hurry, or but you to explain it clearly. And after the explaining it, I would also be showing you the simulation of this with using push buttons. So first of all, here is our circuit. As you can see, this is our first stage that ends up over here. And this is our second stage, which starts from here and ends up over here. In this, you can see the output of the first stage is taken as an input of the second stage, and the output is same as the input of this first stage. I can also show you over here with this by that what is the okay, sorry. Um, so right now here you can यार शिजा अच्छा तुम मुझे बोली थी मानू सॉरी वो मैं So you will have seen that we added I have added another BCD to it so that I could be able to see this input as well. So now our design is really simple and easy to explain. Over here we have added an XNOR gate. An XNOR gate, it basically implements that if both the equalities are unequal to each other, like if this is 0 and this is 1, or this is 1 or this is 0, so it will also produce low logic over here. I have used these logic gates to implement and for the explanation. I would further be explaining it with push buttons and battery, so that you could be able to see that what is the difference created over here. So first, this is created this circuit, presently this circuit, when in the explanation mode, this could be explained easily. So by these small logics, you can also see that these also represents the high and the low logics. This is a low logic which also represents 0 in binary, and this is a high logic which represents 1 in binary. When I'll be doing it with push buttons, for instance, I'll be going to push button. I'll be selecting button over here, then I'll be selecting LED, so I would be able to okay, so I really can I mostly prefer green LED because they have in also. So I'll simply be doing it, I'll be removing it, and then I'll be adding a push button to it. I'll be adding a push button and a battery. Either you can go from here and simply select a DC source, or you can simply go from here to these terminals, and you can select the power option. I prefer power option because it is more reliable. And then simply go here. Right, this is done for this. Right. Now here, I'll be placing a power button and removing all these four options. I'll be explaining you, and you will be able to know it after I've done this. Okay. So now I will be simply adding push buttons to it. The neater your circuit is, the more better it could be explained. So, while creating a circuit, remember that your circuit should be able to be more specified and more neat look, so that if an engineer who does not know what you are doing reads your circuit, he would be able to read it, that how it is performed and how it is can be done. Okay, so. Okay, so I'll be just adding this to here, and now I'll be showing you how does it works. I've added a BCT so you can also read the digital output of it, that how it is implemented. Now in doing over here, I can simply, or I will be removing all of these as well, and then I'll be showing you how it is done. I'll be adding an LED. You can either add an LED or not, because it definitely we are already adding a BCD, so it would be explaining it again. But to just give it a more visual look, I'll be adding it. And ground. Try to make a circuit as much simpler as you can, so that it could be able to explain much neater way. You can see my circuits, few of the things are mixed up, and that's why I wasn't using it instead of just explaining it without. So this is explained like this, so I'll be simply putting it a little bit up, so it could not be mixing over here. This is for the second one. This should be for the third one, and you can simply go from here to fourth one. Okay. I know this is a very difficult scenario created over here, but I will simply show you how it is done. Once I played, all of them are 0, it was giving a negative value. I have to place. Now, assessing it, sorry, first what I assessing it, you would be noticing that there is gray error out here. Gray logic is produced over here. So this defines that the circuit is not working correctly. So what I would do is that I simply go ahead and I'll type resistor that I've already placed over here. If not, then I'll simply go over here and just simply type this. And here I get a resistor. So I simply add it and simply click it out. So I just do simple things that I just add. Oh, okay, sorry for this. Uh, I'll be. Oh, I had to make it clockwise, and I just converted it to. Okay. So now, okay. So okay, I'll be changing it to 100 because this is very high, so it will not be able to move. So I'll simply go from here to here. I know it's a little bit mixing in it, but the reason for it to be is served. You don't need to worry about the circuit right now. It would be created fine. Okay. I'll be arranging them afterwards, so it's not a big deal. Make sure in places like these where the circuits are becoming too much extra crowded, you should be using common terminals over single terminals, independent terminals. You should be using NOT instead of it. So now let's update. I hope so it will be working. Still, oh, I have placed the logic wrongly. Like the register's value should be present over here, and I've placed them the different way. Uh, to make it a little bit more, this way I would be doing this way. Oh, oh. To just make space for the next of it. Let's play it now. Yes. So now it is giving an input. But over here we have been able to produce an we can say is um, a gray logic for this, but over here if you just concentrate over here, you can see that it is giving us the same logic of 7, which explains a circuit of odd being odd. So if I just go for 6, this result is not giving us the right output because of our inputs. So I would be changing them. 3. So now it's the value of it is 3, and you can see that it is 1. So it is also giving us 3. So this is proven for it. Now but this part is not giving us right answer because this is giving us gray logic. So what we would be doing, we would be also
assisting this part. You can change this add resistor to it and it would also be giving you the same output. Now let's going back to our previous circuit which was once created, that could be explained much easier way. Okay, so I have to do it again. Um, this has created a very messed up things. So this is our previous circuit now created as I had shown before the previous circuit in the previous simulation that I had added push buttons and logical gate operators instead of it, so it was also uh, a very logical design and very ideal system would be added over here. These logic props and logic gates states are not available in real life, so these implementations are not very very uh, good as compared to the ones that with the real analysis and real world. So over here, as we can see that it is all zero, so this is also taking it is also taking it as an even output. So even output is converted with one added to it, an odd output. So if we add one, it should be okay. Sorry, if I add two, you can see even over here is converted into odd, but this is again converted into even. Now if I add 1 to it, 3, either now. Okay, so I over here if you see that this output is not connected, that's why the answer was not giving us correctly. I simply connected with the first output and now I'll be going again. So now if you see it, the result had changed. 1111, but 0 here is considered as a new as an even output, so it was giving us 0. So now our circuit explains that how it works, and we can resolve this problem by simply this easily created circuit and much other combination circuits that we can do a different problems. So combination this problems also states that also us makes us to implementation to this realization that when we have difficult logic circuits we could be able to explain them and convert them into better logic circuits just with simple uh, combinations ICs. Other than that, as you problems, we would also be solving this problem regarding addition, subtraction, and multiply, addition, subtraction, multiply, addition, subtraction, and added and subtracted. So this is using a keypad over here. So this we have given the input for using the keypad using, and this is the IC used for the interface of this keypad. That is MM74C C922. This is the IC that we are using, and then we are using BCT codes to implement these circuits. So first in this one circuit, I've only done multiply and adder because the circuit was becoming very um, complicated. You can also do the subtractor and adder in the same time because it just needs one difference over here that it should be added with one. But as I'll be showing you over here that I have done it over here. So if I include it this way, if zero is included, it would be adding the substances. So as right now it is zero and all the number added is zero, and this number would also be two do. So if I add 4, 4 is added, it has gone to add 4 plus 4 is equals to 8, and this results in is the correct results. But if I add zeros, this will result in 0 because this 4 would be implemented as that one. So now I will be going back to my circuit, first one circuit over here. What is happening over here? That is simply this is a multiply IC. I have these are all zero zeros. I replace 5 as one of the output. 5 is implemented over here and the results would be going to the multiplier. The B output would be given from the logic gates and logic props. You can also use a step push buttons and battery to solve it, but for to explain the circuit I would be implementing that. Either you can just in this adder you can either simply give the circuit of direct connections. It would also be giving you the correct answer, but I have implemented it with the XNOR gate to give it more specific implementation and specific logic outputs. Over here, I've simply done addition, and you can see 5 plus 1 is equals to 0, and this is a 0 carry out. So if it is once, it would do the subtraction option. Multiplier IC has the 1 5 multiplied by 1 is equal to 5. So this result is also being included. So by this using this keypad, we can also be resolving our problems and doing it correctly. Jazakallah khair.